everyone, so today's question is validate binary search tree. Given the root of binary tree, we have to determine that whether the given binary search tree is valid or not. So the valid binary search tree is defined as the left subtree of node contains only nodes with keys less than nodes key. So the left subtree nodes will be less than the root, and the right subtree nodes subtrees nodes will be more than the root root nodes. So what we can do is, our intuition can be something like, if we know that in order traversal of a binary search tree, whenever we do in order traversal, we always get ascending order. We always get nodes in ascending order, right? So if we are doing in order traversal, and if any time we see that it's not giving ascending order, in that case we know that the tree is not binary search tree, because if it's a proper binary search tree, in order traversal will always give us ascending order, right? So we'll first write code for in order traversal. For this question, I'll be writing in order traversal using stack, not using recursion, because stack will be better basically. So first I need to mention tree node star cur. So current will be pointing at the root node. Now we need a previous, we'll simply first write the in order traversal code. So for in order traversal, we use a stack, again tree node, okay. Now the in order traversal, what we basically do, we first go down completely to the left, and as long as we can find the left node not null, we'll keep on pushing it in stack, right? So I'll write the condition while car is not equal to null pointer, okay? Or as in the first case, our stack will be empty. So if stack dot empty is true, it's false, right? So yeah, yeah, it's false. So whenever it's false, then yeah. Now again, what basically I have to do, this was the outer condition. Now in over here, I'll say if while current is not equal to null pointer, right? So when current is not equal to null pointer, then we'll completely traverse and push the left node in the stack. So I'll say s dot push current. Now current will be equal to cur left, okay, because we will be going completely in the left side, and once we stop, once we have traveled completely through the left side, we'll get a null point and we'll come out of this while loop. And when we'll come out of this while loop, now our current should point the top of the stack, right? Because that is the last element that we pushed in the top, and now we'll travel its right side, okay? So basically s dot pop, once current, we have the top, now we can pop it. Now I'll just say current will be equal to current right, okay? So right now this code is simply traveling the binary search tree in order function. So what we can do right now is we can set a previous pointer which will hold the previous node's value, and then we can have this current pointer which will hold the current node's value, right? And we can keep on comparing it. If previous is more than the current value, then it will be false, right? So I'll just define a previous node now previous will be pointing to null pointer right now. And over here, once we have popped from stack, I'll say that if the previous should be over here, I'll say that previous should be equal to current. Okay, because in the next line we are changing current's value, so on the top I'm just initializing previous with current. Over here I'll say whenever previous is not equal to null pointer, right, because that is our first condition. So it's when it's not equal to null pointer and previous value is less than, sorry, previous value, yeah, I need to return false. So I'll say if previous is more than or equal to current value, right, then it should return false, right. So basically what is happening, I'm traveling the entire binary search tree in order traversal, and I'm taking two pointers, previous and current. So current will be pointing to the current element and previous is pointing to the previous element. Now whenever previous element is more than the current element, I'll simply say it's wrong and return false. And finally I'll just say return true, because it has completely traveled this entire binary search tree. It came out of the loop and now it will return true. So that is the solution. Thank you so much.